Beyond the vast and empty sky, where darkness dwells forever wide, the eye arrives to question why. The universe has long denied a distant glimpse to those below who seek to see where stars collide. But now the eye can help them know the stars the heavens never showed and share with them their splendid glow. And so they see the night explode with galaxies beyond what shows, a part of space where time has slowed. The eye unfolds from its repose and peers inside the Maker's hand to understand what heaven knows. It then reveals a starry band beyond what man can comprehend, yet held within a grain of sand. Woo!
Whoa.
All right. This was a poem named Webb, apparently, and
that is a good one. Yep.
Was that a good one? Okay, and it's written by I don't know who this is, Angel L. Villanueva. So you can find this on classicalpoets.org. I'm not saying I'm a member, but hey, and I believe this poem is tied to this picture, or one of the many pictures that the James Webb Space Telescope have taken. But before I just blab on, who is actually talking here?
Yeah, what is this?
Hey!
What are you looking at?
It's me.
What are you listening to?
Well, okay, first of all, let me introduce myself. I'm Shen. You can probably see my name down there, actually. What are you listening to? Indeed, you are listening to SG2 on Space, the only weekly space show. Obviously, if you're watching this, most likely you're doing this on YouTube. So at Shen, and also been doing this show for a number of years now. This is episode 213, and today we are going to talk about telescopes in general, and also things about space telescopes. I will also like to say thank you to our supporters. I'm putting the ticker on the bottom: Kyle Baker, Sam Welsh, Sean Graves, for your continued contributions, and then Tumra, of course, for being my very helpful producer for over almost 2 years until taking this show, production-wise on my own. Now, who's the other person, right? I can't just blab on like this.
Well, you could, but hey, Shen.
Hello, Leonard.
What up?
Good to see you. And you're blessed in a way that is you, as always.
Me.
Yeah, I mean, who else wears a headband?
I don't know. I don't see. Sometimes, I mean,
have you met somebody who does that?
Usually homeless people under the overpass and that kind of thing. Unfortunate people.
Oh, I saw. Sorry, I don't mean to detract. Well, whatever. I'm just going to tell this possibly not funny story. But this morning when I was driving to work, I saw these two homeless people greet each other as if they were going to punch each other. One of them was pointing at the other, and the other person was pointing at him, and I was like, are they going to get in a fight right in the middle of the street? And no, one of them was just giving the other person a cigarette, and then they were shaking hands, and they seemed really friendly. So I completely misinterpreted the scenario, and I was like, "Wow, that's pretty kind of them."
I guess I
don't know, but
I don't know. I have a pretty soft heart about people like that, and
they weren't wearing headbands though, so not quite that tribe.
Yeah. Oh, today is September 6th. And it's almost 7:00 Central Time. That's for people who are watching this recorded and stuff. But today was the day that the Starliner, the Boeing Starliner, undocked, and I actually was watching the recording shortly before showtime here, and it successfully. I mean, it's undocked without a crew. I mean, the NASA decided they weren't going to risk the issue.
Right. It's important that we do bring this up because this is important news.
Yeah. So I didn't know. I just wanted to mention that I didn't the test. Yeah, what they call test flight. So it's gone back because NASA decided that that the risk was too great to bring them back, bring the crew back because of the what I thought were pretty significant issues with the propulsion system. But it remains to be seen whether they will be able to return.
Wait, did you say it already undocked? It's just not. It hasn't landed.
Yeah, as of the time that we're talking right now, it undocked about an hour or so prior to us in real time. Okay.
I think so. If you're watching this live, basically, you want to see the Boeing crew flight test. That'd be non-crewed, I guess. Now.
It's uncrewed.
That'd be in 3 hours apparently. So you can watch it on, I'm sure, like NASA TV or something.
Okay, so here I am. I got my fingers crossed that everything will be okay.
Are you gonna watch it?
What?
You're gonna watch it when it happens?
No, but I'm just hoping that everything will be that they'll be able to recover the vehicle. I mean, there's a lot of people who put a lot of work into that, and Boeing's doing
Boeing's currently doing.
Yeah.
Overall, it's good that they're not having anybody inside.
Yeah.
So
I don't know what else to say about that, but we're not going to talk. We're going to talk about telescopes.
Yeah, let's talk about telescopes. So first of all,
what?
Do you have a telescope?
I do have a telescope. I have two telescopes. I have a small telescope that I think it's called a Gregorian. No, it's a Newtonian reflector, and it's a small one that I can use. And then I have a larger one. I think it's a 6-inch Newtonian reflector, and I got it at a thrift store, and I've gotten it to work. It didn't have a counterweight and all kinds of stuff like that. I have gotten it to work, but anyway, I do have a telescope. I'm not a real, astronomy nerd exactly.
You're a physics nerd.
I'm a physics nerd, definitely physics nerd. What?
How do telescopes work?
Well, they work because light can be shaped. The path of light can be shaped by transparent materials, particularly glass, and it can also be shaped by mirrors. And it's quite remarkable that the technology for making glass that was clear enough for telescopes really only came. I mean, glass has been known for thousands of years. Like the Egyptians, you can find glass things in the Egyptian tombs and where people had picked it up as natural, like natural glass from. I don't even know. I think in the Arabian desert it's volcanic glass, and also from meteoric impacts in the desert. So for thousands of years, people have known about glass, and the ancients did have glass. It was refined to a high art in Roman times, but they were
right here, right?
That's glass, but that's not ancient Roman glass.
Okay, I don't have ancient Roman glass. I'm sorry.
Right. So ancient Roman glass, it's quite abundant, but it's the clarity of it is poor. It's greenish from iron contaminants and bubbles and all that kind of stuff. And it wasn't until really the 13th century. Actually, can I share the screen here? Can I share my screen?
Yeah, why not?
I want to try to see if I can.
You want to show the
share.
You want to show the audience some ancient Roman glass?
I want to show them something if I can figure out how this thing works.
You went to Italy?
I did go to Italy. Yeah.
Did you find any ancient Roman glass there?
No, I didn't. Let's see. Darn. I just want to share the window. Oh yeah, this window right here. Okay.
You can do it down there. Okay, let me add it to the stage.
Okay.
There we go.
Yeah.
Okay, you prepared a presentation?
No, I just have some notes. Okay. So this is a picture. This is a painting that was painted in the 14th century. I'm sorry, but in the 12th, in the 14th century by an artist, and I think it's a fresco, and I don't know this artist, Tommaso de Modena. Okay, but the unusual thing about it, what's unusual about this?
Okay, so this is an art test, apparently.
No, it's okay. Okay,
Let
I'll
me
just
see.
let you.
So
I'll
this
just,
is you're saying, okay, so this is it the painting material itself, or is it the actual painting that's
this is
weird?
a picture. Well, this is a picture of a fresco that's in Italy, right? And what's unusual about it is that the dude there is he's got eyeglasses on.
That's right.
Okay.
Because it's like this is the 14th century. So how do they have eyeglasses? Well, do they have eyeglasses?
Yeah.
Apparently.
Well, they did. Yeah. And this is the evidence. Now, how do I stop sharing? Okay.
I'm gonna. You don't have to. Here, going back to you.
Oh.
Maybe let's just do that.
Wait.
I have control here.
That's fine. That's fine. Whatever makes you feel good. So okay. Anyway, so the thing is, this kind of technology, the technology for eyeglasses is the enabling thing. Having glass that was clear enough, and the technology for being able to grind it and polish it was really key to making telescopes. And so what happened was that eyeglasses came online in the what is it, 14th century. I think I said it wrong. It's the 14th century.
It was 14th century.
Yeah. And some of the earliest references in the literature were maybe there's some, it's a little bit, 50 years earlier than when this like around 1305 or around 1300, when people started using these eyeglasses. And it was a big deal apparently, because you think about it, when you start getting to be 40 or 50 or very old like me, you can't see. That's why I'm wearing my glasses today. See, well, actually I can see reasonably well, but that's me. And those
glasses definitely make you look very intellectual, but I'm sure you're also wearing it for practical purposes. Go on.
I'm wearing them because I knew we were going to talk about eyeglasses. So because we're talking about telescopes, and so we're going to talk about the eyeglasses. So anyway, so eyeglasses, and so the ability to make very clear glass, like in the modern, and so the thing about what glass is, it's made from silica, which is like a kind of sand. And in Italy, particularly around Venice, it was, people were working on this for a long time, and they discovered that they could use lenses to correct vision. But nothing happened with telescopes for really 300 years, and it really wasn't until about in the early 17th century there was a guy named Hans Lippershey, right?
Okay, let's see.
What?
I'm just making sure that we got that.
Yeah, Hans Lippershey.
You got
right?
You got a picture of him? I
don't have a picture of him. I just have my notes here. So Hans Lippershey, and so the story was like the story is that it was either his daughters or two people in his shop were he made eyeglasses, right? And two people were in his two girls. It's a legend. It's probably it's an apocryphal legend. They were holding up a convex lens and also a concave lens, and they were like putting them in front of each other. And then they noticed, oh, I can see out the window, and it enlarges everything. And so he put them together in a tube, and then tried to get it patented
You're basically saying it was complete happenstance that like the physics wasn't developed then.
It really wasn't. And this was around this was early 1600s. Which, and it was right about the same time as Galileo.
Right. Everyone knows that. Sorry, I don't want to
interrupt. So the government in Holland, they didn't want to give him a patent because evidently a whole bunch of people all over Europe were doing this. So it's almost like everybody discovered it all at once. But Hans Lippershey wrote tried a patent application, and they didn't give him the patent application, and it's probably because it was sort of probably an obvious, it was already obvious that what was up. So anyway, Galileo got a hold of this, right? He got a hold of this idea, and Galileo. We talked about Actually, we talked about Galileo a lot. Right?
We do tend to talk about Galileo a lot. That's
so Galileo. He was really a professor of mathematics and what they call physics at that time. So he got really interested in it. And there's somewhere I read that they have a recipe, and not a recipe, a shopping list, an actual shopping list that's in his hand, that's written in his hand, and it says glass and pitch and felt and some kind of grinding stones, and then lentils and beets and salad, and so it's like a shopping list.
I'm not kidding. For food and for like telescope.
Right. And I'm not kidding. I'm not kidding about the so he had some idea about exactly, what he was doing. So he was actually grinding these lenses, and so he really got into it. And I think he was doing some mathematics calculations to really understand the optics. And so he was able to get a telescope, I think, that would multiply by something like 10 times using this same principle. And yeah. What?
I'm just trying to see if I can find a picture of his shopping list.
I don't know.
Down somewhere, right? It must be. I did not know that. That's an interesting fact, by the way. Thanks. Continue. Sorry.
So he could make things that would increase the size of objects by something. I might be exaggerating. Might be that high, but whatever it is, he one of the first things he did was he pointed at the he looked at the moon.
I found it. Here's his shopping list.
I didn't lie. I just read about it. I didn't actually see the shopping list.
That's so funny. It's like lentils, white chickpeas, and then it has down here like Greek pitch, felt, mirror to rub, wool.
Right. So I really like that. I mean, it's like a window into the past where you can actually see, what not only was he making the lenses. Anyway, so this is how he made the lenses. I think he went through the factory where he got the glass, and there's a famous place in Italy that had really figured out how to make very clear glass. And I think he went through and tried to find some blanks that were approximately the right size, and he knew how to grind them and polish them, or they learned about it. There's 2 artillery balls on the recipe on the shopping list.
Is that needed for like improving a telescope? What is that?
I have no idea. I wouldn't even know where to get artillery balls, but
I wouldn't know how to get most of these things.
This was 500 years ago.
Well, actually,
but 400 years ago.
Chickpeas. Okay, never mind.
Yeah.
Okay, sorry.
So anyway, he put it together, and so he was watching. He looked at the sun, not the sun. Well, he did look at the sun. He observed
he saw sunspots, right?
He saw sunspots. I presume he was projecting onto a glass because,
Everyone, don't look at the sun, even through a telescope.
So the things that he was able to see were the phases of Venus and sunspots, and he saw the 4 largest moons of Jupiter. When he saw the moons of Jupiter, he did the first time he looked at it, and he took a lot of meticulous notes, right? And so it was very significant because he was able to see all the moons of Jupiter, and also sunspots, and also the fact that, and I think we've talked about this before. I mean, when he looked at the moon, he was the first person in history, really, because we can look at the moon with our unaided eye, and you can't see anything. And I think in ancient times, or prior to Galileo, people thought that things in the celestial realm were like a different plane. They were something like they always wanted it to be perfect, and they wanted it to be idealized. And he looked at the moon, and he saw like craters and mountains, and he was a good artist. He drew a lot of those things.
Yeah, I mean, there's at least, and his writings are still around, so you know.
Right, and so the thing that he did that was really good was that he took a lot of notes. He wrote it down and that sort of thing. But anyway, the thing is that the technology of glass making was very critical to creating telescopes in this era. And the enabling things were they were able to melt glass, the sand, the silica. It needs something called a flux, which is either a sodium or potassium carbonate, and it has to be of high quality, and it will remove the iron in it, and also somehow, I don't know what the physics is, I don't know what the chemistry or physics is, but it allows the glass to melt at a lower temperature and flow, so that all the bubbles will come out, so that you can heat the glass and maintain that for a while. And one of the sources for the carbonate, so the sodium carbonate, potassium carbonate, was very unusual, because these are common chemicals that you can get, from the ground, from mining. But highly purified sodium carbonate was obtained from a plant. There's a plant called salt. There's two plants. One of them called saltwort, and the other one's called glasswort. And if you
named after glass,
they grow in salt water, in seawater, and they concentrate the sodium in the plant fibers. And so when you burn that, the ash is high high in sodium and potassium carbonate. And so that's where that was the kind of almost the secret that they had to making very pure glass, was sodium carbonate flux that's derived from a plant material. I just thought that was interesting. So anyway, Galileo.
That is interesting.
Yeah. So Galileo, we know what he did, and then people were using the telescopes, and what else you want to know? Oh, so Kepler didn't have a telescope at first, but he was in contact with Galileo. I mean, not every day, but he was in contact. And so Kepler designed a telescope where he used a concave lens and then two convex lenses, and it provided a clearer image by correcting
what kind of telescope is that one?
I guess it's called a
Keplerian telescope?
Keplerian telescope. So it improves the design. It's still using lenses, but it has a concave lens or two concave lenses that correct some of the spherical aberration. Spherical aberration has to do with when you use a lens. When you have a lens like this, it will distort or stretch the colors out, and you'll have like chromatic aberration. Objects that you'll see some of the colors are sort of smeared out, and that's one of the downsides to using lenses. And then there was Newton. Got involved in the I think 1660s.
By the way, for anybody interested, we have talked about Galileo, Newton, and Kepler in prior episodes.
We have, yes. So
feel free to watch it.
There was a designer in the mid 1660s named James Gregory, who I think is also an entertainer in modern days, but it's not the same Gregory. So there, a guy named James Gregory, and he had a design for the
American comedian.
a reflecting. Yeah, never mind. Reflect, a reflecting telescope. So it would use a mirror, right? And it would reflect the light back to so it had a concave mirror that would reflect to a convex mirror and then reflect back into the eyepiece through a hole in the primary.
Yes, this particular design, the James Gregory. So yeah, James Gregory, this guy, not the comedian. So if anybody knows James Gregory, we're talking about
this one. Yeah.
This one, not the one that you on the first one.
I would say he's very well dressed. I'd like to have that outfit that he has.
That kind of looks like what you're wearing, sort of.
Yeah, it's something like that. Yeah.
All right, so James Gregory made the next great improvement in telescopes.
But he didn't actually build it. He just designed it. He was a mathematician, and he knew a lot about optics and that sort of thing. And so he didn't build it. So it wasn't built until I don't know, many years later, maybe 20 years later. And I don't remember who it was that built this. And Newton also had a similar kind of design, except that he had a mirror, a flat mirror that would project into an eyepiece, and that would go off to the side. But the Gregorian, this Gregorian reflector, there was a lot of interesting things you could do with it. It had an what they call erect image. In other words, most telescopes, Galileo's telescope and other refracting telescopes will invert the image. Okay, this telescope has the image, right side up, so it's very good for the kind of telescope that you would use it, for practical applications and for binoculars and that kind of thing. This
predates Newton's design, I see, but it's a reflector telescope. Yeah.
Mm-hmm. And the way they made these mirrors, in the early period in the 17th century, they didn't really have glass. They couldn't really control glass well enough to make mirrors out of this. So they used, and I don't remember they used a metal that was a very high concentration of tin and copper.
What is that?
I think it's called speculum or something like that. The metal, so it had a lot of tin, like 20 parts tin and 5 parts copper.
That looks beautiful. This is a 1735 Gregorian telescope.
It is a work of art there.
Yeah.
But the metal they used for the mirrors was interesting. They had to use metal because they really didn't know how to silver glass. They didn't know how to make glass reflecting. This kind of metal was known, actually I think in ancient times. It's a very hard material, and you have to polish it because it gets tarnished easily. So it had to always be polished. But it's a fairly practical way to make mirrors if you can't use glass. So that's the name of that tune.
That's the name of that tune.
Yep.
Okay, so Newtonian telescope. Okay, Gregorian.
Yeah.
Okay, what's the next evolution?
Okay, so the next evolution. So this really. Telescopes had really been well developed, by the 18th century, and a lot of people were using telescopes and making observations. But your eye is still part of the instrument, So up until the invention of photography, that's all you could do, and it's like you could look through the telescope and draw pictures of what you saw. Mm-hmm. And so there's a fundamental limitation. In the 19th century, photography was invented, and there was a guy named Draper. I don't remember his first name, but he got involved. I think privately, he started doing this work to use photographs, and there is a thing called Draper Labs, which I think is named for him.
Probably named after him, right? Yeah.
Mm-hmm. And I don't remember what his first name was, but he was very much involved in Henry Draper.
That's right.
Yeah, that's him. Yeah.
Pioneer of astrophotography. That's great. That's something.
Yeah. And so what they discovered with photograph is, you connect it to a telescope, then you can open the aperture and you can collect a lot of light, and so you can get a very high quality image and see a whole lot more data, collect a whole lot more information than you can with just looking with your eyes. And so he pretty well perfected that, but then he died, and I think he died like before age 50.
He directed an expedition to photograph the 1874 transit of Venus, and was the first to photograph the Orion Nebula. Wow, impressive.
Yeah. They commissioned. So what happened was, okay, another guy that we've talked about is, I think, Edward Pickering. Edward Pickering.
Harvard.
Edward Pickering, and
Edward Pickering, yeah.
And he was at Harvard College, and so Harvard was very interested in mapping the entire sky, photographing the entire sky, and so he wrote to Draper's wife, Mary. I think her name was Mary Draper, and she was very enthusiastic about that also. So they passed along all the technology and all the photographic plates to Pickering, and so that was very enabling kind of photography was very enabling kind of technology in the use of telescopes, and people don't usually think about that very much.
Yeah, and I don't really think about that either until you put it.
I think so Pickering he hired a lot of these actually they ended up being women for some reason. He picked women, I think, because he was kind of prejudiced against the paradoxically he was prejudiced against his male workers because they were out all night playing video games. Well, no, that's today.
Today. What were they doing all night back then?
Anyway, there was some kind of drama about his helpers, and he ended up hiring all women, and it had to do with and one of the women was Henrietta Leavitt, Miss Leavitt, and another one was Wilhelmina.
We discussed these names before. Yeah. Tell me who they are, what they're doing.
Yeah, and so Henrietta Leavitt was a very important figure in astronomy because she discovered the Cepheid variables and developed a distance scale so that we were able to determine distances from the Cepheid variables, which we've talked about before. They knew about this variable star, right? And so the larger the star was, the slower it would modulate. It would oscillate, and it would oscillate over months, weeks to months. And so I think she was a very meticulous kind of person, and that kind of thing. So she almost won the Nobel Prize, I think in the 1920s, but she died before they could award her you're not allowed to win the Nobel Prize
if you're dead.
If you're dead,
So unfortunate.
Yeah. So, but everybody needs to she deserves a lot of credit because
Leavitt deserves a lot of credit for
discovering the Leavitt scale. Yeah, I mean it's kind of a complicated kind of thing, but it was very important to astronomy.
Interesting.
So,
okay.
Yeah.
Going back to the evolution of telescopes.
So, where should we go from here? So in the 1930s, telescopes, Edwin Hubble, he discovered that the universe was expanding, and the Hubble scale. Did he use
what was his? He used observational evidence, right, for that.
Yeah, so doing spectrographic work where you would spread
the Hubble Space Telescope is named after him.
It is, yeah. So what he did was he was an interesting character. He started out life, I think, as an athlete of some sort, and then he ended up doing this. But
yeah, athlete, baseball, football, running track.
Right.
First places and third place in single high school track and field in 1906.
That's interesting. Yeah.
Wow. So different. He could have just kept sports up. I guess he wanted to do math and astronomy. All right.
Yeah. So I think
oh wow, this is a telescope he used. Okay, the Hooker telescope at Mount Wilson Observatory.
Right.
You ever been out there?
What?
Where is Mount Wilson Observatory? If you know.
I don't know. I think California.
Yeah,
but I don't know for sure.
Observatories. Just a quick question: why are they normally built on top of mountains?
Well, you want to get higher up out of the atmosphere, so that the higher you are, the clearer the atmosphere. The atmosphere is clearer, less humid, less distortion from the atmosphere. So that was something that was thought about in the actually in the 20s and 30s. I'm trying to think. If you remember, we talked about Werner von Braun, and there was a book that he read by Oberth, a guy named, I think, Oberth.
Yes.
Do I have that right? Well, Oberth in his book talks about the advantage of space travel, and one of the things he mentions is putting a telescope in space.
That I did not know.
Yeah, and I think Robert Goddard, who was a rocket pioneer that we haven't really talked about very much, but he kind of. I think he also. Yeah. And let's see, Spitzer. I don't know Spitzer's first name, but Spitzer is somebody who's lived in the current.
Hermann Oberth was the first to consider a space-based telescope in 1923. American astronomer Lyman Spitzer discussed
Lyman Spitzer.
Right. The Oberth's idea in 1946, so 23 years later. Okay.
Right. So Lyman Spitzer really got the space telescope, the modern thoughts about the space telescope kicked off in the early or mid 40s, right after the Second World War. So and then that's where we are. There's also radio telescopes, the other using radio waves, which was another thing, which are also very important. So you could consider that a telescope where you use the radio waves. In the early 60s, the microwave background was discovered.
Right, with a radio telescope, right?
Basically a radio telescope. So there was what they call great observatories. So up until so bringing us up in the present day from 1990 was when the Hubble Space Telescope was launched.
So Spitzer was the one who campaigned for a space-based telescope.
Right, and so the NASA got funding for it, but there was a lot of contention about it in the 80s when they were trying to get funding for it. When I was in graduate school, One of my professors, he wasn't my professor, but he taught a class that I took. His name was Odell. I think Charles. Everybody called him Bob Odell, but I don't think that was his name. What?
Like this was your professor back in the day?
Yeah, I mean he taught a class.
Oh, okay.
Yeah, he taught. He wasn't my professor, but he taught a class. I think his name was Bob Odell, but it should be Charles Robert Odell, something like that. I'm sure he's got a Wikipedia page. But anyway, he was the principal investigator, and he was the guy that kind of shepherded the Hubble Space Telescope through funding cuts and then funding uncuts, and then Congress said, we can't afford this. You need to get the European Space Agency involved, and so they got Europeans. So finally, in the mid '80s, they got enough money and they got it all together and they launched it, and with the space shuttle.
This guy, right?
Yeah, Dr. Odell, Professor Odell. Yeah.
That does he look like the person you remember?
Yeah, he's a little older there.
Yeah.
Yeah. I mean, I knew him in the '90s.
Yeah, it makes sense. That was like maybe at least 10 years later.
Yeah, about 1990 or so is when I took a class in. It was a required, one of the classes when I was in graduate school. As I remember, it was pretty interesting, but it was not my field. It wasn't the field that I was interested in. But anyway, so there was a lot of. It was a difficult slog to get Space Telescope funded and launched, and then in 1990 they got it up, right? They turned it on, and everyone was excited, right? And they started observing things, and then I don't think a week went by, or maybe 2 weeks went by, and then there was this horrible news that came out that the mirror, and I think it's a Newtonian. Hubble Space Telescope is a Newtonian reflector.
Right, I believe it is. Yeah,
it has a concave mirror, and then it focuses all of the light to a observation package, an assembly at the focal point. That the mirror had been ground to the wrong eccentricity, the wrong. And I think I remember that it was something like 2 weeks after launch that we got this news coming out, and then there was a mishap investigation where they went through and tried to figure out what had happened. First of all, there was no fully integrated testing of the entire optics altogether, so they thought they had it, and I don't remember the exact details about it. I could probably recover it by looking online. Mm-hmm. But the instrument that measured the figure of the mirror was focused on the end cap of the reference mirror instead of the reference itself. I'm probably not saying it exactly right, but it was some kind of blunder like that caused the mirror to be wrong. And remember, this is billions of dollars, and it was billions of dollars in $1989, $90.
That's
right?
Pretty significant, yeah.
Yeah. There was a lot of, there's a very depressing kind of situation there. But they created a plan to maintain the Hubble Space Telescope was designed so that it could be serviced by the space shuttle. That was one of the things that.
That's right. Yeah.
Yeah, and so they created a mission of the space shuttle to go up in '93. It took 3 years for them to get it all set up. And actually, in the meantime, they were still able to use the telescope. You were able to make measurements and then deconvolve the images with electronics, but it was still suboptimum, with the ability. There, I think this is a picture of the mirror being ground.
At the Perkin-Elmer Corporation Large Optics Fabrication Facility in 1979. More than a decade before. Wow. Okay.
I don't remember the contractor that messed up. I don't think it was Perkin-Elmer. The contractor that messed up was Oh, I can't remember. Something Honeywell kind of comes in mind, but I shouldn't say that because I don't remember exactly. So the whoever messed up, but they did figure out a way to put some lenses in the instrument package. You know, the instrument package, and they did that in '93. They designed some corrective lenses that they put in, and since then it's been a tremendous asset to astronomy, and we've discovered.
How like this one left and right? Is that like this before and after it got fixed?
I actually seem to remember that picture. Yeah, I remember seeing that. Remember that picture. So so that's what had happened.
That's a big difference too. Wow.
Yeah.
Look at that. Right.
And this is all common stuff for us today.
It's like putting eyeglasses, right, on your.
Yeah, it's exact. I think it was exactly like putting some corrective lens on.
Because they couldn't go in there and change the actual mirror. They just had to put more.
That's right. That's right.
Yeah.
So that was a great triumph for the shuttle program, and for them to be able to fix that. It was sort of it wasn't a good thing that they didn't get it integrated directly. About that time, I remember talking to someone who worked in the secret places around the Pentagon, and this is anecdotal, but I was told that there's an agency of the government that's just like NASA, but it's all involved with secret stuff. I mean, that like secret telescopes and looking at the Earth,
right?
And that they had all kinds of insights about how to do the space telescope, but they were not tapped for that purpose and so the technology that was available to the military or to the intelligence services in the United States was very advanced, but was not utilized for the building of the Hubble Space Telescope. So I believe that's true. I believe that's a true thing. That is just an anecdote that I had heard, but I think it's true. So
I would assume that is.
So the Hubble Space Telescope is kind of it has one limitation in that it's really designed, or it's applicable to short wavelength light, like ultraviolet and visible. Well, so which limits our ability to look back in time. So if you look at distant objects, the older things that are further away are stretched out. They're redshifted. And so
telescopes actually have a direct. So basically, explain that a little bit. Telescopes have a direct relevance to how far.
Yeah. So Hubble Space Telescope is designed for visible and ultraviolet, which are short wavelength things, which means that we can only look at things that are relatively close by. I mean, we can see things that are very far away, but if we could see infrared, because the universe is expanding, as Hubble discovered.
The human Hubble
in the 30s discovered that the universe is expanding, and that means that things that are very, very far away have the wavelength stretched out. So something that's at ultraviolet wavelength, like a star, or visible, like the sun, or stars that nearby, that are radiating in the ultraviolet or visible, when they're very, very far away because of the expansion of the universe, because of Hubble expansion, their wavelength is stretched out so that it gets pushed into higher frequencies, red, and then infrared, and then ultimately microwave at the cosmic microwave.
That's a good image, actually.
Right. So now the challenge with measuring infrared is that there's a lot of noise from things nearby, like warm things, and so that's why the James Webb Telescope.
Well, it covers such a huge range on the electromagnetic spectrum.
Well, yeah, I mean, so So anyway, that's what we can do with space telescopes. We can't do any of this with, we can't do infrared very well from the surface of the Earth. We can, but the resolution is poor. So we're still working with James Webb Space Telescope is a tremendous, tremendous thing. I attended a report at NASA last week. It was like a report, and so they've been able to use the spectrum analyzer from James Webb to detect all kinds of interesting molecules, including, like, I think they said sulfur, sulfur containing.
James
Yeah,
Webb.
this is just recently. One thing it can't do, which I found was a disappointment, is that James Webb cannot really directly image or has technology to detect molecular oxygen.
Really?
Right? So,
I thought that was one of the things it said.
yeah, I know. I know.
Okay.
Molecular oxygen doesn't show up in spectra. The things about the spectra are that would be molecules that have a large dipole to them, like water vapor. Water or carbon dioxide doesn't really have a dipole, but it has a central carbon and oxygen. And so the oxygens, they have these vibrational and rotational modes that show up in the infrared, right? But oxygen and nitrogen and those kind of molecules do not. They do not have the kind of modes that show up in the infrared. And so you're making that face, like,
Interesting.
what?
No, I did not know that.
So yeah, that was.
The AI is incorrect then. I mean, I just did a search and it said James Webb Space Telescope can detect oxygen molecules in the atmosphere of exoplanets.
Well, it says that it can detect molecules that contain oxygen. Okay, but it can't detect atomic, molecular oxygen, O2. And the reason that's important is that O2 is a singular signature of life, probably. If we could detect a planet that had molecular oxygen in its atmosphere. Now, what I'm saying this, and I could be misinformed. I'm not misinformed about the ability to use the spectrograph to detect O2. There may be some indirect methods that are available, but this is something I discovered about 2 years ago when I was reading about the James Webb Telescope.
Okay. I mean, I haven't. Yeah. To be frank, I haven't kept up with all the research there. So
yeah. So now in the future, so let's talk. So in the future, I mean, there's another kind of telescope, and it's not a space base, but LIGO, which is the
gravity one.
Gravity wave. Okay, so now objects that are very far away. So there's this very weak gravitational waves that were detected in 2015, and the LIGO gravitational wave observatory, which is 2 laboratories. One of them's in Louisiana, in Livingston, Louisiana, and the other one's in Hanford, Washington. They are regularly observing objects that are things like neutron star collisions, black hole collisions, so this is very exciting because, and so they're getting augmented. In the future, in the next 25 years, we may be able to detect very short wavelength gravity waves. And that's important because the early universe, in the electromagnetic waves, we can't see back beyond the microwave cosmic background.
Yeah, that makes sense.
All right, but gravity waves will go through that, and so a gravity wave. So the light that was emanated at the cosmic microwave background, originally it was an ultraviolet photon, and that over the 13 billion years of time and distance, it's stretched out into the microwaves. Well, the same gravity waves, they're probably at the Big Bang, there was probably gravity waves that were generated and are still emanating out just like the microwave background. and we
That's
just need to
incredible.
develop the
We-
technology.
You're saying with LIGO right now, we can observe the
No,
beginnings of the
not with
universe?
LIGO right now. The
Okay.
LIGO of the future, where we develop this technology over very large baselines, perhaps. I don't really know what the enabling technology is to do this, but we should be able to, we should be able to detect some influences from the Big Bang itself. Things that had occurred at the Big Bang, and that's where I kind of wanted to. That's where we're going to go in the future.
That's pretty incredible.
Yeah,
I'm able to see
we
that.
may actually be able to see the Big Bang in gravity waves. So
Incredibly.
that's
Wow.
kind of all I wanted to say. So that was pretty good. We talked about lenses and
I do want to bring up there's one more.
glass wart.
There's a space telescope, an infrared telescope called the Nancy Grace Roman Space Telescope, under works. And that's supposed to be a NASA infrared space telescope scheduled to launch by May of 2027.
Okay, tell me about it.
I don't know a whole lot about it.
I don't know a whole lot about it either.
So here, let me see. So just to let people know that, this is there. It's supposed to look for, help in the areas of dark energy, exoplanets, infrared astrophysics. So, in terms of, and it's supposed to be at the L2 point. Yeah. Okay. This is just a graphical interface. Obviously, that's not what dark energy is actually like. So,
I'm trying to remember who Roman was.
I mean, it looks fairly sophisticated. This telescope. Oh, who is like the person?
Yeah,
That's a good question.
I know that she was an astronomer, but it seems to me we've mentioned her before, and I can't remember in what context.
Here, let me see. I found a Wikipedia page. American astronomer, stellar classification motions, first female executive NASA, chief of astronomy in the 1960s, visionary founders, created NASA's space astronomy program, known to many as the mother of Hubble, for a foundational role in planning the Hubble Space Telescope.
Okay.
So, music teacher, Georgia, whatever. Okay. So, anyways, I'm
all
sure.
Right. Well, there's a lot of this is very exciting work. There's a lot of orbiting space telescopes now. So, but the
great observatories, that's what they call them, right?
The great observatories, I think, were 4 telescopes.
Like there's a what do you call it? Chandra
Hubble Space Telescope, Chandra X-ray Telescope, which we didn't talk to. That can show like supernova remnants and black holes and different kinds of clusters, things like that. That was Chandra. Compton Gamma Ray Observatory. So there is this phenomenon called gamma ray bursts and other high energy phenomena. So what they call CGRO, Compton Gamma Ray Observatory. What?
Yeah.
And if I remember, Compton Gamma Ray Observatory was launched right about the same time as Hubble. And I don't. What?
Okay, sorry. Go on.
That's all. The Spitzer telescope is an infrared space telescope, but it doesn't have the same capabilities as the James Webb. James Webb is a big deal. Okay.
Yeah, definitely.
Because it's
ever launched. Yeah.
Yeah. So anyway.
There's a good chunk of other telescopes. If you go to the page, you will be able to read some of them. Until next time, when we in some future episode we go over into some of the other areas. Wow, I didn't know some of these even existed. Actually, that's interesting. Huh. But in any case, wow, excellent work, Leonard. You expounded the entirety of the history of telescopes all the way into modern day.
Well, did my best. I don't, when I went to graduate school, I wasn't really that interested in astronomy. I mean, I was really interested in the interplanetary medium, planetary physics and that kind of thing. But I was surrounded by a whole lot of people who were like, they wanted to be astronomers.
Did you ever
and I'm not saying anything bad about that. I'm just saying, but Dr. Odell, who was one of the professors who taught a class, and so
I'm just gonna say this book is pretty good if you're interested in learning about the details of astronomical telescopes. I mean, it's kind of
in the old days, people used to make their own telescopes. That was like a hobby, and you could do
that. I've met people at like those amateur astronomers, like at various like observatories, they just or star parties. Some of them make their own telescopes.
Right. I'm sure that you can still buy the kits, to grind the mirror, and then you take it off someplace to get it silvered or aluminized, and then so I think there's all kinds of directions, or you can buy kits to build it. I know William Herschel in the 1780s. He built a telescope and wrote about that, and then he went and mapped the Milky Way.
He built a telescope, used it to map the Milky Way.
He had a project to his project was to map as many stars as he could in the Milky Way. I think he also discovered I think he also imaged the planet Neptune or Uranus or
Uranus.
Something.
Right.
Yeah.
I think he
did. I say yeah. William Herschel.
Uranus.
There, you said it. Beavis and Butthead. Right. I heard him. Yeah. I heard him say it. Yeah. Yeah.
I mean, that's so interesting that like he built his own telescope and then used it immediately to like map out the whole.
Yeah. Well, I mean, he looks like a nerd. He looks like one of the nerds that we work with.
He looks like what is this thing that he's wearing? It looks like what you're wearing.
Well, that's yeah. I've got some clothing like that. Yeah, but this is late 18th century. I kind of specialize in the 19th century, 1850s. This is like a 1780 outfit, But anyway,
that's a 1785 outfit. Wow, you're almost dead on.
Well, I know when he lived. All right. So anyway, what Herschel did was he had a project where he decided he was going to try to map all of the stars in the Milky Way, and also things like the all of the what they call nebula. Okay, nebula are it just means cloud. So prior to the 20th century, nobody really knew how far away these things were. Right. So all these things.
Mm-hmm.
But yeah.
It seems like we kind of went backwards in time a little bit, but
it's just a conversation, So that's how conversations go.
Sometimes you go forwards in time, sometimes backwards in time.
Yeah.
Now, people 10,000 years in the future watching this show,
they already know all of this, and they actually 10,000 years in the future, they've already mapped the Big Bang. Yeah, they've mapped the Big Bang with gravitational.
Hey, can we see what's before the Big Bang?
Yes. Well, I mean, that's getting out there, because we don't know when time began, really. I mean, Stephen Hawking thought that time began at that point, so he kind of rounded it off, and time turned into like an imaginary number, and it did something. But our one of the people that we've reported on is what? Yeah, is that the other thought is that the Big Bang is a mirror, and that time goes, that you can treat the boundary condition as though it were a mirror, right? Remember that's Neil Turek that we.
Yeah, we talked about Neil Turek.
Right. Yeah. So anyway,
I was wondering, have you read this book? One moment. Let me see if I can share it for our audience as well. Space Time Matter by
No,
Herman
but I
Weil.
will. By who?
Herman, he's like a physicist and philosopher. I don't know.
I don't know. What's his name? I can't see it well. I can't see our screen well enough to.
Here, let me zoom in here. Oh, actually, I just do that. You see it?
I know this name.
He has a lot of the book is
Uh-huh.
like assumes that you know. Well, he, there's a good chunk of math in there, and it'd probably help if some. I've just tried to read it. It's kind of a dense read, but you might be able to read it.
Okay.
So, he proceeds to analyze Euclidean space and then the spatial conceptions of Riemann, and then from that to deriving what like space and time is, and then looks into like Einstein's general theory of relativity, and
Okay, that sounds like my kind of book. Yeah. I had in mind to talk about. I know this is going to sound crazy. I think that we've mentioned.
Never sound crazy.
What?
We always sound crazy.
Yeah.
Whatever you say ends up being the thing you would say.
What?
You said you sound crazy. You might sound crazy, but I'm just saying whatever you say is typically what you would say. So it doesn't sound
It's
crazy.
typically, yeah.
Go on. What were you going to say?
So we've mentioned Carl Jung from time to time.
Yeah, Carl Jung.
Yeah.
I got this book.
Is that synchronicity?
It is immediately after.
Synchronicity?
Not immediately.
Okay.
I want to.
All right. Well, all right. Don't get too tuned up to that. Okay. So there's a lot of controversial things in there,
okay.
and we should do it. We should do a show on Carl Jung and his relationship with Wolfgang Pauli and quantum mechanics. And
next episode.
I think Jung was off track. I think he, but he has some really wild theories that are worth. I think we could have an entertaining show to talk about Carl Jung and his correspondence or his collaboration with Pauli. Pauli was one of the pioneers in the
quantum mechanics.
Yeah, and it has to do with synchronicity. And
so for anybody who have you already read this book?
I have, yes.
Okay, great. So I have to read this book in 1 week so that intelligently.
Yeah. Okay. All right. Now I have another book on the way by, I can't remember the name of the author, but it's somebody that has studied these guys, and that hasn't arrived yet. But so I forgot the name of the book, but I have to look it up.
But it's not by Carl Jung. It's talking about Carl Jung.
Yeah, it's a modern book. Let me see if I can recover the name of the book. I'm gonna go on Amazon.
So
no, it's not Amazon. It was wait. I ordered it from. I'll tell you. Yeah. Now I have the problem seeing. I'm looking.
I can see is that a pink phone that you have?
Yeah. You got a problem with that?
No, of course not. You're a myriad of colors. I would expect nothing less. I mean, you're talking to someone who loves color.
Okay, it's by Paul Halpern. Okay, and he's a personality that you can look up, and the title of the book is called Synchronicity: The Epic Quest to Understand the Quantum Nature of Cause and Effect. So that book is on the way. I haven't read that one yet.
Jung's book is called Synchronicity.
Yeah.
Young's book is called Synchronicity, but now you're saying there's another book.
There's another book. Well, it's Synchronicity with the subtitle. The Epic Quest.
Here we go. I found it.
Yeah. It's that book. Yeah. So that one's coming, and
yeah. Oh, okay. So he named this book after this book because they're both. Well, I mean, the original book is named Synchronicity.
Well, the original book was written in 1959, I think, 58 or 59. Okay, so
sounds about right.
I think we should talk. I think we should not talk about it right now. I think we should do a show on this because it's bizarre.
Like what is this?
Well,
Frequency of aspects per 180 unmarried pairs observed in 32,000.
right. He did he has a whole chapter on astrology because he wanted to investigate scientifically whether astrology and he concluded there's nothing to it.
Wow. I mean,
okay.
It's great that you done some math there. Yeah.
Right. But astrology, but there was another effect that was commonly thought to be true, which was what they call Zener, the Zener test, Zener cards, Zener deck cards, and it was and it was a researcher named Let me look. I got the.
Well, we're definitely going off topic.
Yeah.
Way over.
Yeah.
Time. So.
J.B. Rhine. Okay. So in the late 50s, in the 50s, there was research that was done by a guy named Rhine, who he used these cards, where it had a circle and a squiggly line, and then he was trying to do telepathy. So he was testing people, right? And he got a very weak positive result. And that's all I'm going to say. That's all I'm going to say. And so we'll talk about it. So that'll be like the teaser.
Where isn't it like that is basically the test was to see whether you're psychic, right?
Yeah, whether you had telepathy.
Telepathy. You can tell like what's
right.
in the cards.
Well, Carl Jung was very interested in that. He thought that he didn't do that kind of work himself, but he was very interested in it. But I don't think we should talk about it anymore. I think that should be our teaser for people to tune in.
Extrasensory perception. So next week we will talk about Carl Jung's relation with the physicist Wolfgang Pauli and this book Synchronicity, as well as the other book Synchronicity.
That's assuming I can get it done.
Assuming we get the other book Synchronicity. We'll
talk
about this as well. And also somehow throw in Joseph Banks Ryan in there somehow. Is that right?
Well, Ryan is Carl Jung talks about him in his book.
Okay, throw in this guy's work on ESP stuff.
Yeah.
Like this thing, right? Oh no.
Yeah.
That's probably it. Yeah.
Yeah, that's it.
Interesting. Yeah. Wow. Now, obviously, okay, and we're gonna. Okay, I was gonna say. I wonder what Leonard's views on this are, but we will talk about it next time. So.
Not now.
Not now.
All right, everyone. We have gone way over time, but hey, you know what? If you tried to tune in last week's episode, you probably noticed there wasn't one. So, in a way, we're extending this episode's time. So,
okay.
I like to think of it that way, and rather not.
Right.
We're just talking on.
Anyway,
bad. Point is. Okay, hopefully this has been educational for people 10,000 years in the future. No doubt you know everything, and you'll probably be like, oh, wow, look at these primitives. They don't even know what happened before.
That's right, yes.
But we're sorry. We're trying the best we can.
Yeah.
So,
but, I stand out because it's like, look at this guy. Look how he's dressed.
You definitely stand out because you don't dress like you're in this century.
Yeah.
So.
Like I've heard that before,
The people 10,000 years in the future should realize that Leonard's apparel is not representative of the time that he lives in.
That's true. That's true. Mm-hmm.
So you're more likely to find that if you go back a few hundred years. But, Perhaps. All right. With all that said, jokes aside, to everyone, look up because you never know what you'll see. Thank you again to the supporters, Kyle Baker, Sam Ross, John Graves, and Tim Roth. If you want to be a supporter yourself, you can go to patreon.com/SG2onspace. And of course, feel free to watch this episode again or all prior episodes on YouTube.
I know.
For SG2 on Space.
I know I do.
There you go. Like, subscribe, and share.
Share with your friends.
Share.
Tell them, right. And
all right.
all right. Good night.
Good night. What is it?
Namaste.
Namaste. And the
Shalom.
Shalom.
And good luck to. Let's hope that. Fingers crossed for Starliner.
Yes, that's true. In less than 1.5 hours now, we're gonna set off back to Earth with no humans, but hopefully a land successfully.
Hopefully they'll be able to recover the vehicle. Oh, God. So anyway,
All right.
Carry on.
Carry on with your lives.
Bye-bye.
Bye.